Hello and welcome back to my channel. Today we're going to be talking about volumes of solids, specifically in what we call cross sections. So a cross section is if we take a shape and we slice it, say vertically or horizontally, and we see this shape that it makes. So if we look at what they have here, the base of our shape here is a triangle, but as I slice these down, they are creating this square or rectangle depending on the dimensions of it. So I can find the area of these squares here, and as long as we can tell how it's changing, we can find the volume of this overall based off of that area. Similarly here, we have a triangular base and we have semicircle cross sections. So I can find the area of this semicircle, and then if we can tell what our bounds are, we can integrate it over this area here to get the volume of this entire shape here that looks like that. So the thing with cross sections are, we need to know the area, the formulas for these different cross sections. So ones that we'll see a lot: square, rectangle, semicircle, quarter circle, triangles a lot of times will show up, trapezoids, parallelograms. Some of these you'll see a lot, some of these not as much. I want to say the first part of this is going to be more often than some of the later ones. So things like a square, we know square is base times height, but these bases and heights are the exact same, so we can say it's our side length squared. And we're going to figure out how to find the side length of these things. A rectangle, the base is going to be one thing, and the height has to be given to us in the problem because the base and the height don't have to be the same thing. So when we're looking at some of these formulas, we're going to be using them, but we may either have to figure out what it wants from us, or something has to be given to us in the problem. Some of these here, like equilateral triangle, there is absolutely a way to figure out why it is 3/4. It's a square root of 3 over 4 times the side length squared. And we can figure out exactly how to do that, but I'm not going to do it in these videos. So the big thing that we need to know is that our volume is equal to the integral from a to b, our bounds of the area. A lot of times we call it an a of x equation dx. So this is going to be the area of that cross section. So whatever cross section type it tells us, it is the area of that cross section integrated. So this first one that we have here, it says find the volume of the solid whose base is the region between f of x equals x squared plus 4 and g of x equals 1/2 x plus 1 from x equals 0 to x equals 2, and cross sections taken perpendicular to the x-axis are squares. So here's what we know from this. F of x is x squared plus 4. I know it has to be the one that is curved and hits 4 on the y-axis. So I know this one is f of x. The bottom one has to be g of x. It is a linear equation, and it hits 1 on the y-axis. X equals 0 and x equals 2 are vertical equation or vertical lines. Of course, it's not quite where I want it to be. So it's on the y-axis, and it's not even, didn't help. And at 2. So these are the two places that we want it. So the volume that we're looking at is going to be from 0 to 2 between these things. And we know that the cross sections are going to be perpendicular to the x-axis, and they're squared. So perpendicular to the x-axis just means that all of our squares are facing this way here. So this is where it's kind of hard to visualize what's going on. because it is like these squares are kind of like coming towards you. If I were to try to draw one of our squares in, we'd have our perpendicular between our two lines, and then it might look something like this. So these squares, there's a bunch of them, but it's like if this was the bottom, like if you were to lay it on the table, these squares would be going straight up to the ceiling. So we're going to figure out what the area of this square is, and then we're going to take that area equation and integrate it over our bounds. So first thing we want to figure out is the area of our square. So the area of a square is our side length squared. So if we can figure out what the side length is, we can figure out the rest of the equation. For what we have, our side length is going to be the distance between these two functions. Just like with the area between two curves, we're going to do the top equation minus the bottom equation. So we're going to be using a lot of those similar things. The only difference here is that S is going to be squared. So S itself is going to be equal to the top equation minus the bottom equation. We know the top equation is f of x, the bottom equation is g of x. So I have x squared plus 4 minus 1/2 x plus 1. So I'm going to go ahead and simplify what I can. We have x squared plus 4 minus 1/2 x minus 1, so we're distributing that negative, and then what we really have is x squared minus 1/2 x plus 3. We can kind of leave it in whatever form we want. It just depends on what the question's asking us to do. So we have x squared minus 1/2 x plus 3. So this is what we have for our equation. So our area of our square is equal to our side length squared. So for us, a of x is going to equal that x squared minus 1/2 x plus 3 squared. So this is our side length squared. So this is the equation of the area of any of the squares we have on this entire shape. Now what we need to do is we need to make our equation for volume. So volume is going to equal the integral from a to b. So a is going to be the smallest x value we have, which in this case is going to be 0. B is going to be the largest, in this case it's going to be 2. So we're looking at only values between 0 and 2, and we're going to do the integration of this function. So x squared minus 1/2 x plus 3 squared dx. Okay, so now here's where everything is dependent on what we are doing with our problem. So if this is a calculator active question, they are going to expect you to use the calculator and not do anything by hand here. It could be a free response question. They probably would not make this a free response question, but they might. To which then it depends on if it's calculator or not. If it's a calculator active free response question, we plug this into the calculator and we're done. If not, then we need to do things to integrate it by hand. The things that we would have to do to integrate this by hand is square everything we have here. So multiply out x squared minus 1/2 x plus 3 and multiply it by another one of those. This is going to give us a really large polynomial that we would then integrate, plug in our bounds, and simplify as much as we can. For the sake of what we're doing here, we're going to focus on just how do we set it up, and then we can talk about what it would equal later on. This is now just practicing the skill of integration when we actually do these integration problems. So if you want to try to integrate this, the answer that you're going to get is 466 over 15. This is going to give you a decimal. I believe it's 31.0667. But this is the answer that you would get if you integrate it. For now, we're going to focus on setup. Okay, so that one was squares. We did our side length squared, and we got our answer. This one, on the other hand, is now we're doing cross sections taken perpendicular to the x-axis, are semicircles. So now we're going to be focusing on semicircles here on our graph. So our bounds are the same, the equations are the same, so we know we're looking between 0 and 2. So it's the same bounds. This is still f of x. This is still g of x. The only difference is now we're looking at semicircles. So we're going to have our base here and then a semicircle. It's not quite a semicircle, but that's what we would have. So things that we need to remind ourselves: the area of a semicircle. So the area of a semicircle is the area of a circle and then divided by 2. So the area of a circle is pi r squared, dividing it by 2. Okay, one of the things that we have to remember here is r is radius. When we look at our problem here, this distance here between our two functions is actually the diameter. So when we talk about radius, we only want half. So our radius is going to be the big piece here that we have to figure out. So r is going to equal. We can still do the top equation minus the bottom equation. We just need to multiply it by 1/2 or divide it all by 2. So if I do the top equation minus the bottom equation, f of x and g of x are the same thing. So f of x, x squared plus 4, g of x, 1/2 x plus 1. So we have x squared plus 4 minus 1/2 x plus 1. And then we need to divide all of this by 2. Like I said before, we can simplify this before we put it into our equation. We know that the top part simplifies to x squared minus 1/2 x plus 3, because that's what we simplified it to a little bit ago, divided by 2. And I can either multiply all of this by 1/2, or I multiply each individual thing by 1/2. I personally will just leave it as divided by 2 because I think it's easier. But it won't necessarily look easier in the equation. So if we put it into the area of our semicircle, our a of x equation is going to be pi times r, which is this right here. So x squared minus 1/2 x plus 3 divided by 2. And this whole thing is going to be squared because it's r squared. And we are dividing this by 2. So one of the things is that if I need to figure out what this equals, I might want to simplify what we have here. Things that I can remind myself is that we have a lot of constants here. So I have pi over 2, getting the pi and dividing by 2, the big one. The other thing is if I square something that's in parentheses and there's division, that's the same thing as saying, let's square the top. And let's square the bottom. So I could also factor out a 2 squared, which is 4, to kind of take everything out front to have a pi over 8 as a constant that we're dealing with. But everything we do, it just depends on what we're dealing with. So one way that we could write this is pi over 8 times x squared minus 1/2 x plus 3 squared. So we're going to take this equation right here. This is our area equation for any semicircle that's on this function between these values, and we're going to find our volume. So our volume is equal to the integral from 0 to 2 again, because our bounds are 0 to 2, of pi over 8 times x squared minus 1/2 x plus 3 squared. So we found our area equation. Now we need to integrate it over our bounds to get this function. Once again, I'm focusing more on setup than anything else. If we were to multiply this all out, one of the things that you may notice is that this was in both things. So my answer that we're going to get for this problem is going to be pretty similar, and the answer that we're going to get is pi over 8 times the previous answer, 466 over 15, which means that this is 466 pi over 120. If this is a multiple choice question and it's a calculator section, they'll probably give you the decimal, and we just need to decide pi or not pi being multiplied in. Otherwise, they might give us a fraction like this as an answer. Okay, there's one more with this set up, so let's look at it. Find the volume of the solid whose base is the region between the same exact two equations from 0 to 2, except for this time the cross sections are perpendicular to the x-axis again, and they are equilateral triangles. So equilateral triangles, if we look, our equilateral triangle equation is the square root of 3 over 4 times s squared. So area for equilateral triangle is equal to the square root of 3 over 4 times our side length squared. An equilateral triangle, we're looking at a triangle where all of our sides are the same length. So it's going to be something similar, but probably not exactly the same as that, just a lot of triangles pointing upwards. So what we have here is we need to find that side length. Well, if we look here, our side lengths are all the same, so if I use just the base, then I just need to do the top minus bottom again. So our side length s is top minus bottom, so the top equation minus the bottom equation. Again, so I have x squared plus 4 minus 1/2 x plus 1. But we want to square it because it's our side length squared. I can once again simplify what I have, and we know that it's going to be x squared minus 1/2 x plus 3 squared because we distribute that negative, simplify the singular numbers. 4 minus 1 is 3. We can rearrange it. So all those things to get this exact same thing. So just like before, our volume is equal to the integral from our bounds, in this case 0 to 2 again, of this whole area function. So we have the square root of 3 over 4 times x squared minus 1/2 x plus 3 squared. So we have the same function again. So we're multiplying this thing again, something squared, that thing squared, times the square root of 3 over 4. So we don't have to do a lot of work once we know what that is. It's just the square root of 3 over 4 times that same 466 over 15. This is going to give us 466 over times the square root of 3 over 60. If we were plugging into a calculator, we could just get the decimal and then we would be done. So the big thing that I want you to get from these problems using the same exact equation is just the fact that the only thing that's different is the area function that we're using. We may have to think a little bit differently about the area function depending on the side length we need, but they're all pretty similar to each other. If we can find the area of one cross section, we just integrate it over our bounds and we are done.